This is the study guide for Geometry Unit 3. We're going to cover these questions quickly. On problem number 1, the sum of the interior angles of a quadrilateral equals how many degrees? So a quadrilateral is any figure that has 4 sides. So this here is a quadrilateral. It has 4 sides in a shape. Okay, so this is actually a theorem, Theorem 319, that tells us the sum of the angles of a quadrilateral is 360 degrees. If you look it up, Theorem 319. Also for this, they ask the sum of the interior angles of a triangle is how many degrees, and it's 180. That's Theorem 317. Now I'm going to tell you how this works, how you find the sum of interior angles for any polygon. Now, so the sum of exterior angles, excuse my speaking this afternoon. The sum of the exterior angles for any polygon is 360 degrees. So they ask, what is the exterior, the sum of the exterior angles for a pentagon? In this case, it's 360. Any polygon is 360. Now, when you're looking for the sum of interior angles, they ask you on problem number 4, what is the sum, what is the equation for the sum of interior angles of an n-gon? So an n-gon is any side. A pentagon is a 5-gon, has 5 sides. A hexagon is a 6-gon. But this can go all the way up to ones that don't have names, like a 20-gon. All right? So the equation is this. The sum of the interior angles equals the number of sides minus 2 times 180. The reason why this works, we'll use this pentagon right here, is you take from one vertex and you draw all the diagonals to the vertexes you can. So a hexagon, a pentagon, which what this is, 5 sides, you can draw 2 diagonals to other vertices, causing 1, 2, 3 triangles. That's why you multiply by 180. You take the number of sides, in this case it's 5, minus 2, always minus 2, and times it by 180. So the equation for the sum of the interior angles of an n-gon is the number of sides minus 2 times 180. All right, problem number 5, they ask, an exterior angle of a triangle equals the sum of the blank interior angles. So they're asking, this is one of your theorems, this angle is equal to the sum of the remote interior angles. So in this case, angle 4 is going to be equal to angle, wrote that backwards, angle 1 plus angle 2. So it's called the remote interior angles, or the 2 angles that are not, the 2 angles that are not connected to the exterior angle. Problem number 6 says, a triangle can have 2 right angles, true or false? A triangle cannot have 2 right angles. We covered this earlier, I think maybe in last unit, or it could have been in this unit, that a triangle can only have 1 right angle because the sum of the interior angles of a triangle is always 180. If 2 of your angles had right angles, if 2 of your angles were right angles, we wouldn't have a triangle. We would actually have a square. It's impossible for a triangle to have 2 right angles. All right, problem number 7, they give you 6 different kinds of polygons, and they want you to identify them. So number 1, they ask for a scalene triangle. A scalene triangle is a triangle that has all different sides. No 2 sides are the same length. So you're looking for a triangle with all sides different lengths. All sides different, okay? Obtuse. An obtuse triangle has one angle that is bigger than 90, okay? You have right triangles, and then you have ones that are less than right, which are acute. Obtuse is going to have an angle that is larger than a right angle. so it's not going to be straight up and down. And then the other two are going to be actually smaller than 90 in that case. Hexagon. A hexagon is a 6-sided polygon. So look for a polygon with 6 sides. A right triangle. So a right triangle is formed by perpendicular lines. It's always set off by one of these squares in the corner. That lets you know this is a right triangle. It equals 90 degrees. A pentagon. A pentagon has 5 sides. It's a 5-sided triangle. A 5-sided polygon. And a quadrilateral is any polygon with 4 sides. All right, so it doesn't have to be square or rectangular, but it does have 4 sides. Always has 4 sides. 4-sided polygon. So remember, check your number of sides and in the scalene and the obtuse. Scalene, every side is a different length, and obtuse, one angle has to be larger than 90 degrees. All right, problems number 8 through 15, you'll notice they're not questions, they're just statements, okay? It's because these are all true statements. You need to know some may be true and false on your test. Sometimes, some may be sometimes, always, never questions. So you got to know the truth. So I'm going to just go over them and explain them so you know. Number 8 says, one angle of a triangle is obtuse. So if you remember from the last problem, if obtuse means it's bigger than 90 degrees. So say this angle is 100 degrees. It says, the sum of the measures of the other angles must be less than 90. This is true because if this one is over 90, so in this triangle, you know, every triangle has to have 180 degrees. This one only has 100. This one has 100 degrees taken up. It's obtuse. More than 90, that means we only have 80 degrees left. Anytime you go over 90 in one of your angles, you're going to have the other two have to add to less than 90 degrees. Number 9, it says an acute triangle can be isosceles. So now you have an acute triangle. That means one of your angles is less than 90 degrees. So say this one is 20 degrees. So in this triangle, 180 degrees, 20 is taken up by this acute angle right here. That means we have 160 degrees left. So an isosceles triangle has 2 sides equal. 2 angles are equal and 2 sides are equal. So what they're saying is it can be isosceles because each of these angles could be 80. And 80 and 80 would make that 160. That would make an isosceles triangle. But also in this 160, one could be 100 degrees and one could be 60. So yeah, it could be, an acute angle could be isosceles. Also, it doesn't have to be isosceles. It could be scalene. In number 10, a regular polygon is a polygon that all sides and angles are equal. So, not all triangles are regular polygons. A scalene triangle is not, but an equilateral triangle, where all sides are equal, is a regular polygon. A square is a regular polygon. Okay, so it's the difference between just a polygon and a regular polygon. A regular polygon, all sides and angles are equal, as in a square or an equilateral triangle. Number 11, a hexagon is a polygon. Yes, anything that's a shape with sides is a polygon. A square is a polygon, a triangle is a polygon, a hexagon, a pentagon, everything, a 20gon, as long as it closes, it has sides and it has shape, it's a polygon. That's what a polygon is. Number 12, the measure of an exterior angle at the vertex of a polygon sometimes equals the measure of the adjacent interior angle. So it says the measure of an exterior angle at the vertex of a polygon. So let's go with a rectangle here. Any polygon, this should work with squares or... So an exterior angle here in this rectangle, this is an exterior angle, it's on the outside. Because this rectangle has 90 degree angles here, then yes, these are equal. But this question says, the measure of an exterior angle at the vertex of a polygon sometimes equals the measure of the adjacent interior angle. So these are equal to each other, the exterior and the interior. But that's only going to happen with right angles. In this case, say this angle is a right angle here, and this one is 20 degrees. That means this one is 70. These are supplementary. This one's actually going to be 110. Okay? So, yes, they can, the interior and exterior can equal if it's next to a right angle. It's never going to happen unless it's next to a right angle. Number 13. An exterior angle of a triangle can never be 180 degrees. Okay, so you have a triangle. We covered earlier that the exterior angle is equal to the sum of the remote interior angles. So this angle is never going to equal 180 because there has to be 180 in here in all three of these. So if these two added to 180, this would be 0, and then you want to have a triangle, you just have a line. Problem number 14. There are never 310 degrees in the sum of the interior angles of a polygon. So if you'll remember, to find the sum of interior angles, you take the number of sides minus 2 and times by 180. So why can 310 never be the sum of the interior angles? Because every sum of interior angles of a polygon is going to be a multiple of 180. It's going to be 180 times something. And 180 times 2 is 360. Skips right over 310. 310 is never going to be the sum of the interior angle. So the sum of the interior angle has to be a multiple of 180. Number 15. In a regular polygon, all of the interior angles are equal in measure. So we covered this already. A regular polygon, all the angles are equal and all the sides are equal in a regular polygon. All right, problem number 16 says, in a right triangle, the acute angles measure x plus 10 and 3x degrees. What is the measure of the smallest angle of the triangle? All right, so they tell you it's a right triangle. So that means one of the angles equals 90 degrees. That means the other two have to add to 90, because 90 plus 90 equals 180. So these two together have to add to 90. So they tell you x plus 10 and 3x. So you add those. X plus 10 plus 3x should equal 90 degrees, which would finish my triangle. All right, so solve for x. Combine like terms. You have 1x and 3x, which gives you 4x plus 10 equals 90. So 4x, we want this 10 to move to the other side. It's going to subtract over here. 90 minus 10 is what was supposed to go there. 90 minus 10 is 80. And then 4 is multiplied to x, so the opposite of multiplication is division. 80 divided by 4 is 20. So that means x equals 20. So for the first, they ask, what is the measure of the smallest angle? So now we got to put x in here and find out. So 20 plus 10, or 3 times 20. Which one's smaller? 20 plus 10 is 30, and 3 times 20 is 60. So your smaller angle would be 30 degrees. 30 degrees and 60 degrees. 30 and 60 add to 90, so 90 and 90 is 180. So that is correct. Number 18, they ask, number 17. Approximately how many degrees are in the measure of an interior angle of a regular 9-sided polygon? So that means it's regular. That means all the angles and sides are equal. Right? A regular polygon. So the equation is the number of sides minus 2 times 180. And because it has 9 sides, it's going to be 9 minus 2, which is 7 times 180. So go ahead and do that on your calculator. 7 times 180. And that'll tell you how many degrees are in there all together. What you need to do is divide that answer by 9. Because that'll tell you how much each one is specifically. They ask for the measure of an interior angle. So you're going to multiply these, then divide by 9. Because that's how many angles there are. Problem number 18. They give you this figure. And they say, if the measure of angle 2 equals 122 degrees, and the measure of angle P equals 46 degrees, what is the measure of angle O? So this is an exterior angle. So if you'll remember, your exterior angle is equal to the sum of the remote interior angles. So the measure of angle O plus the measure of angle P, not 9, P should equal the measure of angle 2. We know the measure of angle 2 is 122 degrees. And we know the measure of angle P is 46 degrees. So the measure of angle O is actually going to equal the exterior angle minus the one interior angle you know. So 122 minus 46 will give you this angle here. Number 19, they tell you that L is parallel to N. All right, that's your given. And they want you to find the measure of angle 3. If the measure of angle 5 is 71 degrees, and the measure of angle 6 is 54 degrees. So what we need to remember is because they told us the lines are parallel, that means our remote interior angles are equal. So 5 and 2 are called remote interior angles. They're on opposite sides of the same line. So that means angle 2 is equal to 71 degrees. Now, they want the measure of angle 3, which is your last angle of a triangle. And we all know a triangle equals 180 degrees. So if you'll take 180 degrees minus 54, minus 54, which is the measure of angle 6, and minus 71, which is the measure of angle 2, you will get your answer for the measure of angle 3. So because a triangle adds to 180, you subtract the two angles you do know, and you'll find the measure of your last angle. The last two problems, problem number 20, they give you this figure, and they want you to find the measure of angle 1. All right, so we need to know, the way we can figure this out is that this is a 90-degree angle here, making this a 90-degree angle here. And because it's cut into two, which I didn't do very well, but these two here are complementary. They should add to 90. So if one of them is 40, the other one is 90 minus 40, which is 50 degrees. So this angle right here is 50 degrees. And it is a vertical angle with this angle right here. I didn't draw it very well, but it should look like this. Okay, this angle equals 50, and they're vertical angles. So this one also equals 50. Now you know your two angles of your triangle, and the last one has to equal what? So you want to go 180 minus the 90 degrees and the 50 degrees. 18 minus 9 is 9, and 9 minus 5 is 4. So that means this angle up here has to be 40 degrees. 90 plus 40 plus 50 is 180. And again, on problem number 21, I want you to find the measure of angle 1. They say, assume the transversal is perpendicular to N. So they tell you, assume that this line right here is perpendicular. And they also tell you that L and M are parallel. So these is not, they say assume it's perpendicular, which gives us a right angle right here, 90. So we have 180 minus 90 is 90 degrees, minus 30 is 60. That means this is a 60-degree angle here. And then vertical angles are equal. So if that angle is 60, then the measure of angle 1 is also 60 degrees. All right, make sure you know your theorems. not just the answers I gave you, but the reason why. And you will do very well on this test.